Hello everyone, welcome back to my YouTube channel and welcome to my playlist The Wrong Way. So this is the first video in this playlist The Wrong Way, and today we are going to learn about the different ways to compile C++ code. And as always, as promised, I've always start with the not so good way, which you can call the wrong way, and then we'll progress into seeing how to do it a better way. Okay, so let's get started. So in this example that you can see that we have a very simple C++ code. It just declares an integer a, and it just declares an integer a, right? And let's try to compile this. So keep in mind that this is not about writing the best C++ code, but this lecture is about writing compiling it in a better way. Okay, we'll see that in a minute what does it actually mean. So let's try to compile this code. G++ code 1.cpp. So yes, it got compiled, and let's try to run it. Let's even try to add a hello world. Hello world. Okay, compile it again. Yeah, we can see that it printed a hello world. So this is one of the way to compile, which is not the best way actually. This is in fact a bad way. So the first thing that we should notice is that whenever we are compiling a C++ code, we should always name our object file that would be created. Okay, so that would be using the O flag, and then we can name our object file which is similar to our C++ file name. So we can name it like code underscore one dot out. Let's try to run this. So now you can see that we can compile this using code one dot out. Now why is this important? Now this is important because let's say you have a different file in C in the same directory, and you compile it, and without using this object name flag, so your a.out will be overridden, right? So you don't want that. You want uh, all of your C++ file to have their own separate object files. Okay, so yeah, so this was one of the way. This was the first improvement. In fact, let's write it actually. So let's write the first one. The first one was G++ code 1.cpp. This is how we compile, right? This is the, so we are progressing. So this is the second way, not the second way, the second step actually. Let's now see the third step. Before that, let's declare a few other variables. Int x equals 5.5, int y. Okay, so now let's try to add this so let's try to compile it using the same command. So as we can see that it got compiled, but let's try to run it with a WALL flag. So WALL is nothing but warning all. So it enables all the warning. In fact, not all the warnings, but it enables most of the warnings. We will see how to enable all the warnings. So it enables most of the warnings that we can have. So let's try to compile it first, and then let's read. Okay, so let's read all the warnings one by one. So it says that warning unused variable a. Okay, warning unused variable x. Okay, so it again says that this variable is unused, and this variable is also unused, and this variable is also unused. So basically it throws the warning for these three variables. So This is nothing but a warning. It gives you a hint that you should do something to fix it, or maybe you can ignore it. So yes, let's copy this and paste this here. Okay, didn't get pasted. Anyway, I'll just write it w all. So w all doesn't mean all the warnings, it basically means most of the warnings, and we will see how to enable all the warnings. So you can write w flag w extra. Okay, g++ code minus object file code underscore one dot out and warning all and warning extra. Okay, so this is to enable all the warnings, like all the extra warnings. Let's compile this, and yeah, so you'd see the same set of warnings which we saw in w all, but it will actually enable some extra warnings too. Like if we had those relevant code, it would show, but yeah, for now you can assume that this will enable the extra warnings too. Yes, this is another improvement you can have. Copy this and paste this extra. Okay, now one another thing which you can add is that this might be a overkill, like we might not even want it, but if you want, you can say that see, usually what happens is that if we compile it and it gives a warning, we might ignore it, right? Like, okay, let me give you an example. Hello world, this is let's code for fun. Okay, so what happens if I have all this warning and then I still try to run this code? You can see that code one dot out. So you can see that this code still compiled, right? I mean, it did not happen that this code did not compile. It, even though it threw the warning, it successfully compiled and it even ran. So what if we, so this can like bring in some bad habit that we will ignore all the warnings. So sometimes what you would want to do is, like, you can even include, okay, wait a second. So sometimes what you would want to do is, like, you might want to throw an error if any of this throw a warning. So let's try to run this. Yeah, now you can see that this is an error. This is no longer a warning. Now your code is not compiled. Okay, so yeah, be careful about this. Yes, and okay, so this is fine, and let's try to copy paste this command again. Copy. Okay, this is getting a little wide, and this is done. Now there's one more command which I wanted to show. Is there's one more flag, in fact. Let me try to reset this. One final piece of flag which I wanted to discuss was the std flag. The std flag is basically the flag which describes the standard. Okay, so like the version of C++ which you want to run. Let's say if I do something like C minus std equals C++, let's say 17. Okay, so this would compile it using the C++ 17 standard. Let's try to run this. Okay, this won't compile because we have this w warning error. Let's remove this and run. I will show you the difference, where the difference happens. Okay, now let's say we have a pair int p equals 1 2 and f equals p. So this feature is called structural binding, and this is only available in C++ 17 and beyond. So we will try to run this. Let's remove all this code and let's try to run this. Okay, so this says that the structural binding is set but not used. So this is just a warning, right? Now let's try to uh, compile it using C++14. Okay, so now you can see that it is saying the structural binding only available with C++17. So it's not available with C++14. So you can see that this is how we can use this std flag. And okay, so let's copy this. And actually there is one more which I missed, and I think that's worth mentioning. Let's, oh my god, what happened? That's actually quite interesting. Yes, in fact that is more interesting than some of the flags which we have used. So let's say that we are using this okay, let's remove all of them, all of this code. And let's try to print this. Okay, so here we can see that let's say compile it using C++17. Here you can see that this compiles, right, and without throwing any warning, and then we can run it. Oh, okay, sorry, not a.out, not a.out. We have to compile it using code one.out. So it compiled successfully, and wait, I'll do it once again so that you are not confused. So I compiled it and I ran it, and it says 5. See, this is where the problem is. Sometimes what happens is that we inadvertently assign a float to an integer, and then in the runtime we see that all of this is happening. So to avoid this, we can add a flag, w conversion. This is in fact one of my favorite flags, w conversion. This will warn you about if you are doing something like this. Let's see. So let's see what it reads. It reads conversion from double to int changes. Okay, let me just expand this. The conversion from double to int changes value from 5.5e to 5, right? You can see that it's very clearly stated in the warnings. So yeah, this is one of my favorite flags. Okay, let's, oh my god, people can have favorite C++ compilation flags. That's not a good sign. Okay, so now you can see that like we have this huge string. Like this is the next thing which I'm going to tell you is a very bonus tip. And since this is something which is a very long line and you are not going to write it all the time, I can give, let's try to use some Linux tips, and we can use it to create an alias, not an alias. In fact, since this will be dynamic, it will be better if we create a function. So let's create a Linux function which will wrap the whole thing inside of, let's say, uh, a function, and then we can just use the function with the file name, and we'll get our object file. Let's try to see how we can do it. So I've copy pasted this command, and we will see what this command actually means. This is actually a bash function. So let's write something like g++ strict. Okay, so this means that when we will run g++ strict command in this terminal, this is how it will take. So it will take a g++ and then $1, which means that the first command line argument, and it will create an object file by removing the cpp part and doing that out, and then it will append all these extra flags. So let's see how do we like make it work. So for that you need to open your bash rc file, bash rc. I'm using vim, you can use any other text editor if you want. And I'll go to the bottom, and I'll just copy paste this. Okay, give some space. Yes, and now let's let's verify this once. Yes, this is fine. Now let's close this, and let's do a source and yes, now we will see how to run this. Okay, now let's make some changes here. Okay, let's say int y equals hello world. Okay, and let's not use this variable because we want, and yeah, see, so we have two problems, right? So here the problem is that it should warn about the x being like this 5.5 being set to x, which is an integer, and then this y variable not getting used. So let's try to use this g++ strict. So g++ strict, and what is the file name? The file name is code1.cpp. okay, so let's try to compile this. Then okay, g plus does not name a type. Okay, I think actually this should be removed. Okay, so let's compile this again. Okay, this is actually an error. So string, change this to string, and let's compile again. In fact, you would have seen that. Okay, so now you can see. Let it go away. So let us see. So I actually changed this string as to this integer because it was causing some issue. We will discuss that later. So for now, you can see that I'm using g++ strict and code1.cpp. Let's try to run this. And when you're running, you can see that this is again giving you the warning that conversion from double to integer changes value from 5.5, and you can see that we are not specifying any flags over here because this all those flags are actually encoded in this g++ strict function. So yes, I hope this was helpful. I hope you guys would have taken some good lesson. And let's at the end write create an alias for the whole, not an alias, create a bash function for the whole for all the flags. Okay, I hope this was helpful, and make sure you guys use this actually, because if you just learn this and not use it, then it won't be much useful. You will forget it very soon. And yeah, I'm expecting to make more such videos, and yes, see you there. Goodbye.